In this video, we are going to begin some quiz 2 review and focus on the multiplication principle and counting unions. So our goals in these videos are simply to do some practice problems to help review for the quiz. So the scenario that I want to look at in this video is a social security number has 9 digits. How many social security numbers, part A says, are there total? So I want you to begin by pausing the video for 1 minute to try this question on your own first. 4, 3, 2, 1, pause the video. Pause it for 1 minute to try part A first. Alright, so hopefully you've done that. Hopefully you paused it for a minute to try this. This time is really the most valuable time, especially in these quiz review videos. It gives you a chance to see how well can I do problems like these on my own. Alright, so let's talk about it together. So a social security number has 9 digits, and the digits can be anything in the set 0, 1, 2, comma, up until 9. So there's going to be 10 choices for any of the digits. So I can just make a slot for each one of the digits. So first digit, second digit, third digit, then I'll put a dot, dot, dot up until the last digit, the 9th digit. So there's no conditions on part A, like whether it doesn't specify anything like having no repeated digits like part B does. So that means there's 10 choices for each digit. So I'm going to write a 10 in each of these spots. 10 in the first, second, and third spot, as well as the 9th spot. And we want to multiply these values together because these are different steps in the same process. Okay, and there were 9 digits that we selected. So we are multiplying 10 by itself 9 times, which gives us 10 to the 9. And that's our answer. All right, so let's look at part B. So part B asks, how many social security numbers have no repeated digits? So just like with part A, I want you to first pause the video. This time, again, for 1 minute to try this question on your own first. 4, 3, 2, 1. Pause the video. Pause it for 1 minute to try this question on your own. Alright, so hopefully you did that. Hopefully you paused it for a minute to think about this. So I am again going to think about this in terms of how many choices do we have for each digit. So I'm going to put a slot for the first digit, a slot for the second, a slot for the third, and then I'll put a dot, 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 and then a slot for the last one. So for the first digit, there are 10 choices. 10 choices for that first digit. So I'm going to write a 10 in that slot. But once we pick that first digit, because we can have no repeated digits, we have 9 choices for the second digit, because it could be anything except for the first. So this could be anything except for the first. Anything except the first digit. All right, so let's put a 9 in that slot. And in fact, let's move this whole thing up a little bit to give ourselves some more room here. So let's move this up a little bit. All right. And let's fix that. Alrighty, there we go. So once we've picked those first 2 digits, now there are 8 choices for the third digit left, because it could be anything except for the first 2. Anything except the first and second digits. So 8 choices there. And if we keep going like this, when we get down to the last digit, there have been, so this is the 9th digit. There's 9 digits in a social security number. which means up until this point, 8 digits have already been chosen. So there are 2 choices for this spot, 2 choices. So let's write a 2 there. And if I multiply these out, we get 10 times 9 times 8 times ... up until times 3 times 2. And this is super close to 10 factorial. It's just missing that times 1. But we might notice that if you multiply this thing by 1, it doesn't change what it is, because multiplying a number by 1, it keeps it exactly the same. So this is exactly the same as 10 times 9 times 8 times ... times 3 times 2 times 1, because the 1 doesn't change anything. So it actually is the same thing as 10 factorial. So that's kind of nice there. So I'll leave that as 10 factorial. And let's look at part C. So C is asking how many social security numbers either begin with 3 or with a 5. So for this, I want you to pause the video and try this on your own for 2 minutes. We're upping the difficulty a little bit with this one. So 2 minutes to try this. 4, 3, 2, 1, and pause that video. So hopefully you've done that and paused it and tried this for about 2 minutes. So I'm going to begin by letting A be the set of social security numbers that begin with 3. So I'm going to put this in set notation. So I'm going to write SSN for social security numbers. So SSNs beginning with a 3. And then we also care about the set of social security numbers beginning with the digit 5. So let me call that B. And when the question says the word or, it makes me think of union. So specifically what we're trying to do here is we're trying to figure out the number of elements in the union of A and B. The set of social security numbers that begin with a 3 or that begin with a 5. Okay, and this is going to be equal to, well, one of the things I notice is that A and B, these 2 sets, are disjoint. I can't have a social security number that begins with a 3 and also begins with a 5. So these 2 sets are disjoint. So these are disjoint. And when they're disjoint, and I'm counting the number of elements in their union, it's just equal to the number of elements in A plus the number of elements in B, since A and B are disjoint. So we do not need to subtract the number of elements in the intersection of A and B, because there are no elements in the intersection of A and B. Okay, so I'm going to highlight this. So this is one of our key equations from our chapter on counting. All right, and now let's work out the number of elements in A and the number of elements in B. So for the number of elements in A, I want to count the number of social security numbers that begin with a 3. So let me put some slots. 1, 2, 3, ... up until the last slot. So for the very first digit, there is one choice, because it has to be a 3. In the set A, my social security number begins with a 3. So let's put a 1 there, because we only have one choice for what digit to put there. But for all the other spots, we will have 10 choices. 10, 10, 10 in all of those spots. So in all of these remaining 8 spots, so 8 times, we will put the number 10 in. And multiplying this out, we get 10 to the 8. So let's do the same thing for counting the number of elements in the set B. So social security numbers that begin with a 5. Again, I'm going to draw some slots. 1, 2, 3, ... The 9th one. So for the first digit, we have one choice, because now we want it to begin with the digit 5. So I'm going to put a 1 in that spot. And then for each of the other digits, we can pick any of the 10 choices. So we'll put a 10, and a 10, and a 10 in each of those positions. So just like before, we are putting a 10 in 8 times. And if we multiply this out, we get 10 to the 8 power. Okay, so we are ready to write down our answer. So I'll put an implication arrow. So the number of Social Security numbers beginning with a 3 or of 5 is just this first 10 to the 8 we got added to this other 10 to the 8 we got. And if I wanted to simplify this, this is kind of like doing x plus x, something plus itself, which is 2x. So in that way, 10 to the 8 added to itself would be 2 10 to the 8. And that's my answer. If the question asked me to simplify this and work out what the number is, I could go ahead and do that with a calculator, but I will go ahead and leave it like this. So let's do one more part to this example. Now I want to find the number of Social Security numbers that begin or end with a 3. And this or is an inclusive or. So for this one, I want you to pause the video one more time, this time for 3 minutes, to try this one on your own. 4, 3, 2, 1. Pause it, and try this one for 3 minutes. Alrighty, so hopefully you did that. Hopefully you tried this one for about 3 minutes. So just as before, I'm going to let A be the set of Social Security numbers beginning with a 3. But this time, I'm going to need a new name, like C, for the set of Social Security numbers ending with a 3. And what we're trying to do is we're trying to count the number of elements in the union of A or C. So the word or, just like in part C, makes us think of a union. All right, so in this case, Social Security numbers that begin with a 3 and Social Security numbers that end with a 3, these are not disjoint. These are not disjoint. Because you could definitely have Social Security numbers that do both, that begin with a 3 and end with a 3. So there's definitely some elements that are common to both. So when I count the number of elements in the union, it'll be equal to the number of elements in A plus the number of elements in C, but minus, I got to subtract the number of elements in the intersection of A and C. So that's because A and C are not disjoint. And I'm going to highlight this formula as well. This is another key formula that we've gone over for counting the number of elements in a union when our sets are not disjoint. Okay, and in part C, we already found the number of elements in A, the number of Social Security numbers that begin with a 3. That was 10 to the 8. So that is 10 to the 8. Okay, but I'll need to work out the number of Social Security numbers that end with a 3, as well as the number of Social Security numbers that are in the intersection. That means they'll begin with a 3 and end with a 3. So let's do that next. So let's count the number of elements in C. These are Social Security numbers that end with a 3. So let me draw some slots. First digit, second digit, third digit. And let's go ... second to last digit, and then last digit. So the last digit, we're going to have one choice because this needs to end with a 3. So I'm going to put a 1 there because we have one choice. But for all the other digits, we have all of the choices available to us. So I'll put a 10 in each of those spots. And overall, my Social Security number has 9 total digits, which means there are 10 choices for each of these 8 spots. So 8 times we're putting in a 10. And only in the 9th digit there's just one choice. So multiplying this out, this is 10 to the 8. All right, now let's do the number of elements in the intersection of A and C. So these are going to be social security numbers that begin and end in a 3. So let's put out some slots again. So put a slot, 2, 3, ... and then I'll do the last 3. 1, 2, 3. So there's one choice for what we start with. It's got to be a 3. And there's one choice for what we end with, because it has to be a 3 as well now. So let me put a 1 for both of those spots, because there's one choice for each of those. But for all of the remaining digits in the middle, we can do any of the 10 digits. So 10 choices here, 10 choices here, and continuing like that, 10 for each of these spots. So we have one choice for the first digit and the last digit, but that still leaves 7 of these digits, 7 times that we've had 10 choices. And multiplying this out, we'll get 10 to the 7. All right, so we are ready to write down the number of social security numbers that begin or end in a 3. It was the number of social security numbers that begin with a 3, 10 to the 8, plus the number that end with a 3, that's what we just found here at the top of the page, 10 to the 8, minus the number of social security numbers that both begin and end in a 3, subtracting the number in the intersection, which was 10 to the 7. And I could simplify this a little bit if I wanted to. Like, we already did 10 to the 8 plus 10 to the 8 in the previous part of the question. And that was 2 times 10 to the 8 minus 10 to the 7. And I'll just leave it like that. So in the next quiz review video, we will do an example where we review permutations, combinations, and complements.